Key concept 11, target C.
Yeah, YouTube channel is at Mad Videos by Mr. A. Make sure you subscribe so that way you know when new videos come out. Hit the notification button as well. I'll be making videos for Key Concept 6 through Key Concept 14 for Integrated Math 1 Core and Honors.
Alright, target 11C is about factoring and solving quadratic equations. So, just to recap here, standard form of a quadratic function is ax squared plus bx plus c is equal to 0. Factors are values multiplied together to give you a product. So, let's say, for example, my product is 20. Factors that would give me that product of 20 could be 1 and 20, 2 and 10, 4 and 5, and so on. In order for us to be able to factor, we must be given the quadratic in standard form. So again, we're going to be given an equation in standard form, and we need to come up with the two quantities that multiply together to give you that quadratic function. Okay, so what does it mean to do it algebraically? You want values of x that will result in y being equal to 0. So you want to know which x value, okay, so let's say, I don't know, x equals 5, right, that I can plug back into here and here, that will eventually give me an answer of 0. Okay. In this case, the graph that I have here, here's the x-axis. The y value would be 0 here. However, that's 1, 2, 3, 4, 5, 6. That's the ordered pair 7, 0. And this one is the ordered pair negative 1, 0. So in that case, if I were to plug in the x value negative 1 and the x value 7, it would give me a y value of 0. Okay, so yeah, down here it says graphically, what does it mean? It's x-intercepts, so the graph of a quadratic function. Okay. Alright, so we're going to start off with, what if we have to factor and solve quadratic functions when a equals 1? Remember, a is a leading coefficient. Okay, so these examples that we're going to see now, a is going to be 1. Later on, we'll see examples where the coefficient of x squared, a, is not 1. Alright, so step 1 says make sure the quadratic is written in standard form, ax squared plus bx plus c. Okay, and then you could add here equals 0. There'll be some examples where it's equal to 0, and then there'll be other examples where it's equal to f of x, which is the same thing as y. Alright, step 2 says find two numbers, n1 and n2. I labeled them n1 and n2 because n1 is going to be the first number, n2 is going to be the second number. They're not going to be written as an ordered pair like that. I was just trying to show you that I'm finding two numbers. We want two numbers that when we multiply them together give us this c right here, but then when I add those two same numbers, it gives me that b from right there. Okay. 3 says write the factor form as either x plus or minus the first number times x plus or minus the second number equal to 0. Once we do that, we're going to see each quantity equal to 0 and solve for x. Okay, so this can be a little bit tricky, but we'll work through it example by example. So example 1 says factor and then solve the following quadratic equation. So step 1, the quadratic is written in standard form. X squared plus 8x plus 7 is equal to 0. Check. So the first one is true. 2 says find two numbers that when you multiply them give you c, but when you add them give you b. Okay, so we want two numbers that when we multiply them, I'm going to put a dot here for multiplication, multiply to c, but when I add them, give me b. Okay, so looking at c is the value 7, and b is the value 8. So I want two numbers that when I multiply them give me 7, but when I add them give me b. I always start with numbers that multiply to give you c because they're a little bit less possibilities, especially because 7 is a prime number. So the only numbers that I can multiply together that would give me 7 would be 1 times 7. And then I need to see if they'll satisfy the other condition. When I add them up, will they give me 8? So using the same numbers, 1 plus 7, sure enough, gives me 8. It looks like 1 and 7 aren't going to be the numbers that I need to. All right. So step 2 was find two numbers that multiply to c and add to b. We found those. The numbers were 1 and 7 in this case. All Right? The next step says write the factor form as x plus or minus the first number times x plus or minus the second number equal to 0. Okay, so we're going to have two quantities, set them equal to 0. The first value will always be x, because keep in mind, when I multiply x and x, that's going to give me this x squared. That's why both of them need to have an x at the beginning. Now, in the second space of both of the parentheses, I'm going to put the numbers. It really doesn't matter which order in this case. The 1 was positive, so I'm going to bring it down as plus 1. The 7 was positive, so also bring it down as positive 7. Okay. Now, the first direction was to factor. That right there is factor form. So we finished the first thing. Now we need to work on the second one, which says solve it. Okay, so we move on to step 4, which says set each quantity equal to 0 and solve for x. So here's the first one we're going to set equal to 0. X plus 1 equals 0. And then the second one is x plus 7 is equal to 0. Okay, and those are just equations that we're going to solve each one. Get x by itself, we're going to subtract 1 from both sides. Turns out x is equal to negative 1. And then the other equation, subtract 7 from both sides to get x by itself. Turns out x is equal to negative 7. Now these right here is us solving it. So factor form was a quantity x plus 1 times the quantity x plus 7 equals to 0. Once we solved that, we found out that the answers was x equals negative 1 and x equals negative 7. Okay. Now, let me try to make a little bit of sense of all this. Let me just prove to you that this really is a factor form. So I'm telling you that if I take x plus 1 as a factor and I multiply it by the quantity x plus 7 equals 0, I should end up with this again. So let's distribute like we did in the previous target. X times x will give me x squared. X times 7 will give me a positive 7x. 1 times x is a positive 1x. 1 times 7 is a positive 7, still equal to 0. Okay, combining like terms, we bring down x squared. 7x and 1x combine to give us 8x. Bring down the constant positive 7 is equal to 0. So you'll notice that this right here is the same as the first equation that we started with. Okay, so really what we did is we worked backwards. Before we might have been given this right here, but now we're given this over here. And we need to work backwards to figure out what the factors are. Hence the name factor form. Okay. Now, I told you what does it mean to solve an equation or solve a quadratic equation? Is finding x values that when we plug them back in will give us the y value 0. So let's see if that's true. The original function was x squared plus 8x plus 7, and we want to see if that will really give us 0. Let's start by plugging in the x value, negative 1, here and here in parentheses. So in parentheses, negative 1 raised to the second plus 8, parentheses, negative 1 plus 7. Negative 1 raised to the second is going to give us positive 1. 8 times negative 1 is going to give us negative 8, and then we have add 7. 1 plus negative 8 is going to give me negative 7. Negative 7 plus 7 is sure enough going to give me 0. So that one checks. Let's check the other one. Again, we have the standard form x squared plus 8x plus 7, but now we're going to plug in negative 7. So we have negative 7 raised to the second plus 8 times parentheses negative 7 plus 7. Negative 7 squared is going to give us 49. 8 times negative 7 is going to give us a minus 56. Bring down the plus 7. 49 minus 56 is negative 7. Negative 7 plus 7, sure enough, is going to give us 0, and it's true. Okay. One other thing that you don't have to do, but I just want to show you, is if we were to graph this, right? So first things first, if you remember from, I believe, target 11A, when A is positive, that means I have a parabola that opens up. Okay. So this tells me right here, A is positive 1. I have a parabola that opens up. These right here tell me where do they cross the x-axis. So let's say this was my graph, right? We have a parabola that opens up and it intersects at the x value negative 1. And the x value negative 7, which might be somewhere over here. and then it opens up. Okay, it's not an exact sketch of the graph, but it's pretty close based on the few information that we know. Okay, now keep in mind everything to the right was just is extra work, just so to show you, try to explain what was going on. Factor form was this one right here, and then the solutions were these right here. Okay, those would have been the answer for number 1. All right, so we have example 1 continued here. I included all the steps just as a reminder for us. We did example A in the previous slide. Now we're looking at example C and E. I'm skipping B, potentially D, and if there's anything else after E, those will be your responsibility to finish, right? And I'll go over these a little bit faster. I try to go over example A very detailed so you can sort of understand what's going on here. The only difference with C and D, or sorry, C and E, would be potentially that instead of a plus sign, there might be a minus sign or whatnot, just to show you that it really doesn't matter what sign it is, the process is still the same. All right, so looking at C. Step 1, make sure the quadratic is written in standard form, ax squared plus bx plus c. Sure enough, x squared minus 11x plus 28 is equal to 0. It's in standard form. Now, it says step 2, find two numbers that when you multiply give you c, but when you add give you b. Okay, so we want them to multiply to give me c, which is 28. But when I add them, give me b, which is going to be negative 11. Okay, big difference there. In the previous example, we saw that I believe they were all positive. Here, b is actually negative 11. All right. So factors of c. We have 1 and 28, always the simplest one, right? 2, if we divide 28 by 2, we will get 14. So 2 and 14. Not divisible by 3. Should be divisible by 4. So 28 divided by 4 will give us 7. Not divisible by 5. Not divisible by 6. We already found out the 7 times 4. And I believe those are all the factors. Okay, 1 and 28, 2, 14, and 4 and 7. All right, now a combination of those also has to give us a sum of negative 11. Okay, now if we're going to have a sum of negative 11, that means some of those numbers to the left that multiply to give us 28 have to be negative. However, if I make only one of them negative, that's going to give me a product that's negative, and I need a product that is positive. Okay, so I had to consider potentially making both of them negative. Now, 1 and 28 will never give us a sum of negative 11. 2 and 14 will never give us a sum of 11 either, no matter how we change the negatives. 4 and 7 might. Okay, if we did negative 4 plus negative 7, we should get a sum of negative 11, which means I have to change the signs over here too. A negative 4 times a negative 7 should give us a positive 28. So step 2, find two numbers that multiply to c. Negative 4 times negative 7 give us positive 28, but add up to b, negative 4 plus negative 7 give us negative 11. Alright, so in step 3, write the factor form as x plus or minus the first number times x plus or minus the second number equal to 0. Alright, so we have x minus 4, because it was negative 4, times the quantity x minus 7 is equal to 0. So step 3 is also done. Step 4 says set each quantity equal to 0 and then solve for x. Alright, so we have the first quantity x minus 4 is equal to 0. The next quantity x minus 7 is equal to 0. Solving each one, we add 4 to both sides. Turns out x is equal to 4. In this case, add 7 to both sides. X is equal to 7. Okay. So again, directions here were to factor, which would be this right here, and then to solve, which would be these two answers right here. All right. Moving on to E. Okay. Make sure it's in quadratic form. Yep. X squared plus 7x minus 18 equals 0 is standard form. Find two numbers that multiply to give us c. So we want to do times c. C being negative 18 in this case. and we want them to add up to b, which is a positive 7. Add b, which is positive 7. Okay, starting with c. So again, we need factors that give us 18. So 1 and 18. Okay, notice 1 and 18 would give us a positive 18. So one of these definitely has to be negative, but I'm not going to worry about that just yet. And then we have 2 with 9. We have 3 with 6. And I believe those are the only factors of 18. Okay, now 1 and 18 will never give us a sum of positive 7. 3 and 6 will also never give us a positive sum of 7. So 2 and 9. However, here's a trick here. Either the 2 or the 9, one of those has to be negative in order to end up with a product of negative 18. However, we want a sum of positive 7. So because the sum we want is positive, the sign is positive, that means out of the two numbers 2 and 9, the bigger one must be positive, so that when I add them up, I still get a sum of positive 7. So that means the 2 must be negative. And then you want to double check your work. Negative 2 plus 9, sure enough, is positive 7. So I found my two numbers that multiply to c but add up to b. Now the next step here says, write the factor form as x plus or minus the first times x plus or minus the second one. So in this case, we have, doesn't matter which one you put first, I'm going to go ahead and put x minus 2, x plus 9 is equal to 0. And then we're going to set each one equal to 0 and solve for x. So we have x minus 2 equals 0. And I'm just going to put it over here because I'm running out of space. X plus 9 is equal to 0. Solve each one. Add 2. Turns out x is equal to 2. Over here, subtract 9 from both. And x is equal to negative 9. Okay, so directions again were factored out, which is that right there. And then solve, which is this right here. Alright, looking at example 2. Example 2 says factor and solve the following quadratic equation. So the directions are the same. The only difference here is that you'll notice, like for example a, it's x squared minus 16 equals 0. That is in quadratic form, even though it doesn't seem like it. It's in the form ax squared plus bx plus c equals 0. The only thing here is there is no bx term. It's canceled out completely. Ax squared is x squared, c is minus 16 here, and there's no bx. Okay, so if you look up top of the directions, this is what we call a difference of squares. Now, difference tells us that we're subtracting, and it only works with subtraction, not with addition. And what we're subtracting are squares. So remember, square, when you raise something to the second power, you could say that it's that value squared. So we're looking at two things that have been squared and are being subtracted from each other. So step 1 says make sure the quadratic is written in the form a squared minus b squared. Now, don't think of the a and b here in this formula as the a and b from the standard form of quadratic function. A and b here means two things completely different. Then step 2, write the factor form as a plus b, a minus b is equal to 0. Notice it's almost the same quantity written twice, except for the difference that one is a sum and one is a difference. And then step 3 is the same as before, set each quantity equal to 0 and then solve for x. Alright, so example A, we have x squared minus 16 equals 0. So x squared, we have to rewrite it as something being raised to the second. 16, we have to rewrite it as something being raised to the second. And sure enough, they're being subtracted, so it is a difference of squares. X squared is the same thing as x being raised to the second, so that one's already good to go. Minus, we need to rewrite 16 as some number raised to the second, which is going to be 4 raised to the second is equal to 0. So what we have now is a difference of squares. Okay, A is going to be x, and B is going to be 4. So step 1 is done. So when we do step 2, it says write the factor form as a plus b times a minus b. So that's going to be x is a plus b is going to be 4. Close it up. Now we need to write a minus b. A was x, b was 4. Okay. And then 3 says set each quantity equal to 0 and solve for x. So we have x plus 4 is equal to 0. And we have x minus 4 is equal to 0. Solving each one. So we're going to subtract 4 from the first one. Turns out x is equal to negative 4. For the second one, we're going to add 4 to both sides. And x is going to be equal to 4. So, first set of directions was to factor. We did that right here. That right there is factored form. Second set of directions was to actually solve it, which is this right here. Okay. Now what I'm going to do now is I'm just going to, again, if at any moment you feel like maybe, let's say at this point right here, right, your factored form, you're not sure if you did it correctly, you can always work backwards to see if it's true. Okay, so in this case, x times x is going to go ahead and give you x squared. X times negative 4 is going to give you a minus 4x. 4 times x is going to give you a positive 4x, and then 4 times negative 4 is going to give you a minus 16 is equal to 0. Negative 4x plus 4x cancels out, and you'd be left with x squared minus 16 is equal to 0, which sure enough is the quadratic that we started off with over here. Okay, just prove for yourself that when you factored it, you did do it correctly. All right, and that would basically be it for A. Now moving on to example B. We have 4x squared minus 9 is equal to 0. Sure enough, it's written as a difference of 2 squares. So we need to rewrite 4x squared as some value being raised to the second. There's a minus. We need to rewrite 9 as something raised to the second. So we have 4x raised to the second. That's going to be the same thing as 2x being raised to the second. Okay, because 2 to the square, or 2 to the second power is 4. X squared, sure enough, is x squared. And then minus 9 we can rewrite as 3 raised to the second. Okay, so this quantity right here, 2x, is going to act like my A, and this 3 right here is going to act like my B. Okay, so now we're just going to rewrite it as A plus B, A minus B. So we're going to have 2x minus 3, 2x plus 3 is equal to 0. And then we're going to set each one equal to 0 and solve for x. So the first one is 2x minus 3. Now you don't need a parentheses there. Is equal to 0. And then we have 2x plus 3 is equal to 0. And we're going to solve each one. So first thing we're going to do is add 3. We have 2x is equal to 3 divided by 2. Turns out x is equal to 3/2. That's as simplified as possible. The next one, we're going to subtract 3. It's going to give us 2x is equal to negative 3. Divide both sides by 2. And that's going to give us x is equal to negative 3/2. Okay. Now, the one thing I forgot to mention, and I should have mentioned in the first example, is why we set each one of these equal to 0. Okay. That's what we call, that should be a star, the zero product rule. Okay. Which says, let's say I have A times B equals 0, right? So we have two things being multiplied together and their product is 0. If their product is 0, then A must be 0, right? Because that's how we would end up with 0. Or B must be 0. That's how we would end up with 0. Or they would both need to be 0 to give us a product that is 0. Okay, so the zero product rule basically says when you have two things being multiplied together and their product is 0, then at least one of them must be 0, or if not, both of them. That way we would end up with a product of 0. Example 3, solve for x. We're looking at A, which is 2x squared minus 13x minus 24 equals 0. Okay, now we're looking at a different set of directions this time around because we're looking at the steps to factor and solve quadratic functions when A is not 1. And the process changes quite differently for when A is not 1. So, first step, make sure the quadratic is written in standard form. Ax squared plus bx plus c equals 0. Sure enough, 2x squared minus 13x minus 24 equals 0 is standard form. Step 2 says, if possible, factor out a greatest common factor or GCF from all three terms. Okay, a greatest common factor is basically if they have something in common that you can divide out. So, for example, let's say we were looking at the numbers 5 and 20, right? the biggest factor they have in common, the biggest number I can divide both of them by would be 5. So looking at 2x squared minus 13x minus 24, they don't all have x, so I can't take that out. 2 and 24 are both divisible by 2, but 13 isn't, so they have nothing in common, so we can skip number 2. Now, 3 is where we need to pay a little bit of attention. 3 says, find two values that give the product AC and the sum B. All right, so this is somewhat similar to before, except before the product was just C. Now we're looking at AC. Okay, so AC in this case, A is 2, and C is negative 24. Okay, so we want two numbers that give you the product of 2 times negative 24, which is negative 48. And then when you add them, give you the sum of B. Okay, in this case, B is negative 13. So again, I start with my factors. We have 1 and 48. We have 2 and 24. We have 3 and 16. If you don't know off the top of your head, which I didn't either, I had to do 48 divided by 3. We have 4 and 12, not divisible by 5. We have 6 times 8, not divisible by 7. We already have 8. I believe that's going to be all of them. Okay. Now keep in mind the product has to be negative, so one of these has to be negative. I'm not going to worry about that just yet. I'm going to start looking at the sum of negative 13. 1 and 48 would never give me 13. Neither would 2 and 24. 3 and 16 might. 4 and 12 would never give me 13. Neither would 6 and 8. So potentially we're looking at 3 and 16. Now, again, the product is negative 48. So either the 3 or the 16 has to be negative. The sum was negative. So that tells me the bigger one out of those two factors must also have the same sign so that when I add them, I still get negative 13. So we're looking at 3 and negative 16. So we finished step 3. Find two values that give you the product AC and the sum B. Now, number 4 says, rewrite the middle term using those two values. So we want to rewrite minus 13x using the numbers 3 and negative 16. So I'm going to bring down the first term, 2x squared. That's not going to change. I'm going to bring down the minus 24 equals 0. That's not going to change. I'm going to rewrite minus 13x using 3 and negative 16. Okay, and it doesn't really matter which order you put them, so I'm just going to put them in the order I saw. Positive 3x minus 16x. Okay, I expanded it, but if I were to combine 3x and a minus 16, that would go ahead and give me back to negative 13. So all I really did was rewrite the middle term like the directions said. Now, number 5 says split the 4 terms in half and factor out the GCF from each pair of terms. So if we split it in half, 2 on the left, 2 on the right, and then they want us to factor out the GCF. So they want to know what do they have, what's the most they have in common that I can divide out. 2x squared plus 3x, looking at the coefficient 2 and 3, there's nothing in common, but they both have an x that I can take out. Okay? And whatever's going to be left will go in parentheses. So if you take 2x squared and you factor out or you divide out an x, all you're going to be left with is 2x. Okay? So if we were to go and distribute again, x times 2x would give me 2x squared. We have positive 3x. If we factor out an x, we're just going to be left with a positive 3. So again, if we were to go back and multiply, we'd end up back with what we had before. Now the next one, minus 16x minus 24. We want to know what's the biggest they have in common. They both don't have x, so we can't take out an x. We want to figure out what's the biggest number you can divide 16 and 24 by. They're both divisible by 2, but there's a number even bigger. They're both divisible by 4, but there's a number even bigger. They're both divisible by 8. So let's say I decide to take out a positive 8. Okay, you take negative 16x divided by positive 8, you're going to get a negative 2x. If you take negative 24 divided by a positive 8 that you factored out, you're going to get a minus 3. Now, that's okay, but our goal is to get whatever's in the both parentheses to be exactly the same. And you'll notice on the left, in the parentheses, it's 2x plus 3, but on the right, it's negative 2x minus 3. They're almost the same except for negative. So that tells me that instead of factoring out a positive 8, I probably should have factored out a negative 8. Okay, so I'm going to have to go back and check this out. Now, this is something that you want to keep in mind before you do it or as you're doing it. Okay, I purposely made the mistake because I wanted you guys to see what would happen, and if the parentheses are not the same, then that tells you something went wrong. So now if I factor out a negative 8, I should get what I want, which is 2x plus 3 inside the parentheses, set it equal to 0. Okay, the parentheses should be the same if you did it correctly. Now, step number 6 says factor out the GCF from the resulting expression. So looking at this and this right here, that whole thing is an expression with two terms, right? The rectangle on the left is a product. The rectangle on the right is also a product. What they both have in common is 2x plus 3. So I'm going to factor that out from both of them. If I take it away from the one on the left, I'm left with an x. That's going to go in parentheses. If I take it out, or if I factor out from the box on the right, I'm left with a minus 8, again, which forms its own parentheses, and it's still equal to 0. This right here is what we would consider factored form, okay? Significantly different than the previous examples that we did, all right? Now, continue working the problem. Now we set each quantity equal to 0, and then we solve for x. So the first one, again, the zero product property, we have two quantities being multiplied, and they give us a product of 0. So at least one of them has to be 0, if not both of them. So we have 2x plus 3 equals 0, and x minus 8 is equal to 0. Subtract 3 from the left, you get 2x is equal to negative 3. Divide both sides by 2. Turns out x is equal to negative 3/2. Add 8 to both sides to the other one. Turns out x is equal to 8. And those would be the final answer. X equals negative 3/2 and x is equal to 8. Okay, so again, process is different. Now, the nice thing is this technique that I just showed you could actually be used when a is equal to 1 as well. It could even be used when we did the difference of squares. Okay. The only reason I showed you a different method for example 1 and for when we did difference of squares is because those are supposed to be shortcuts. Technically, this right here is the way you would want to do it all the time so that you would only need to memorize one technique. However, the shortcuts do save us some time. Okay. We're still looking at example 3. We're going to example 5. Again, a little bit faster because I already went over one example with you guys. Step 1, quadratic form. Standard form, sorry. 5x squared plus 42x plus 16 equals 0 is standard form. Step 2 says factor out a greatest common factor from all of them if possible. 5, 42, and 16 do not have any number in common that they could be divided by, and none of them, or at least not all of them, have x, so I can't take out an x either. Moving on to step 3. Find two values that give you the product AC and the sum B. Okay, so AC, A would be 5, C would be 16. 5 times 16 is going to give you 80. And then numbers that add up to B. So plus B would be a positive 42. Okay, so we have 1 and 80, 2 and 40, not divisible by 3, 4 and 20, 5 and 16, right? The numbers that we just multiplied together. Not divisible by 7, 8 and 10. Let's see, 9, no, 10 we already have, 11, no, I don't think it's divisible by 12, by 14, no, by 16, we already have 17. I think we have them all right there. It's possible I'm missing one, but I think we have all of them. Now, we need them to add up to 42. 1 and 80 won't do the trick. 2 and 40 sounds like it might. 4 and 20, there's no way it gave me 42. 5 and 16 wouldn't do it either. Neither would 8 and 20. So it looks like 2 and 40 are going to be our numbers. Alright, rewrite the middle term using those two values. So we're going to rewrite 42. So we bring down 5x squared. Bring down plus 16 equals 0. and we could bring down the 2 or the 40 down first. Now, it really doesn't matter which one you bring down first. However, notice that in step 5, when you split them in half, you're going to have to factor out the GCF again. So if 5x squared is the first one, you might want to think to yourself, does 5x squared have more in common with 2 or with 40? I'm thinking 40 because I can divide both of them by 5. So I'm going to bring down 40x first and then plus 2x. Keep in mind, I'm only doing it because I think it'll help me out a little bit. If I were to write down the 2 first and then the 40, my work might look a little bit different, but I would end up with the same final answer. Alright, so we're done with step 4. Step 5 says split the 4 terms in half, so 2 on the left, 2 on the right. And we're going to factor out the GCF. So looking at the left, 5x squared plus 40x both have an x, and they're also both divisible by 5. So I'm going to take out a 5x. 5x squared, factor out or divide out a 5x, and you're left with just an x. 40x divided by 5x is just going to leave you a positive 8. Doing the same thing on the right, 2x and 16, they do not both have an x, but the greatest number that they're both divided by is 2, or both divisible by, which will leave me x plus 8 in the inside. Remember, our goal is to get the parentheses to be the same. In this case, they absolutely are. But you also want to factor out the greatest thing that they have in common. Now, we have a product here, and we have a product here. They both have an x plus 8 in common, so like step 6 says, factor out that GCF from both. I factor out from the first one and from the second one, and whatever is left will form its own parentheses. So in this case, 5x and positive 2. Okay, that right there is what we would call factored form. So if the directions were to just factor, we'd be done, but we still need to solve it. Okay, so we're going to set each one equal to 0. You have x plus 8 equals 0, and 5x plus 2 equals 0. In this case, we just had to minus 8 on the left. Turns out x is equal to negative 8, part of our answer. On the right, subtract 2 first. You end up with 5x equals negative 2. Divide both sides by 5. Turns out x is equal to negative 2/5 is the final answer because the directions were to solve for x. Alright, moving on to example 4, solve for x. Now we can use the same directions as, or the same steps as the previous example. These are just slightly different. So looking at A, 2x squared minus 8x is equal to 0. That actually is in standard form. The only thing is that we have ax squared plus bx, but there is no plus c. Okay. However, it's still in standard form. It's just missing something. So rather we move on to the step that says factor out the greatest common factor from both. So they both have an x, and they're both both divisible by 2. So we can take out a 2x, and then whatever is left after we factor it out or we divide it out will go inside its own parentheses. So 2x squared, factor out a 2x or divide it out, you're left with just x. Negative 8x divided by 2x gives us just a minus 4. Okay. Now at this point it looks a little bit different, but if you wanted to, you could put 2x in parentheses so that it reminds you this is actually factored form right there. Okay, so if the directions were to just factor, we can stop right there. However, the directions were to solve for x. So we set each one equal to 0. Remember, 0 product rule, which basically says if there's two quantities being multiplied and they give you 0, then one of them must be 0, or both. Dividing both sides by 2, turns out x is equal to 0. On the right, add 4 to both sides, and x is equal to 4. And that would be the final answer for part A. Okay, taking a look at the one for C, we have 6x squared minus 9x minus 6 is equal to 0. So again, we could multiply A and C right away. A is 6, C is negative 6, which would give us negative 36. And then we can start looking for factors of it. Negative 36 is not necessarily a huge number. It wouldn't be too much of an issue. But in order to make the numbers a little bit smaller, the steps from the previous example say that what we could do is look at A, B, C and see if there's anything in common, if there's a greatest common factor that we can divide out. They don't all have x, but they are all divisible by 3. So I can take out a 3 from the entire thing. So 6x squared, take out a 3 or divide it out or factor it out, would leave us 2x squared. Negative 9x divided by 3 would give me a minus 3x. Negative 6 divided by 3 would give me a minus 2. And it's all still equal to 0. Okay, and actually, we don't need the parentheses after the 0. It could be after that and then set it equal to 0. Now, process after that would be the same. So we want two numbers that multiply to give me AC. A in this case now 2, before it was 6, times C negative 2, when before it was negative 6, which will give me a product of negative 4. And the B that's going to add up to is now a negative 3. Okay. So again, the numbers are a little bit smaller to work with now. Factors of 4, 1 and 4, 2 and 2. Obviously, one of them has to be negative to give me the product of negative 4. 2 and 2 would never give me negative 3. I'm going to keep the negative with the 4 because when I add them, I want the answer to still be negative. So the numbers we're looking at are 1 and negative 4. Okay. Now this 3, I'm just going to go ahead and bring it down. It's still part of my answer. I just don't need it at the moment. So we keep ax squared the same. We keep c the same. The only thing is we rewrite the middle term. So again, in any order you want, I'm going to go with positive 1x minus 4x. And then we split it down the middle. Factor out the greatest common factor. 2x squared and 1x only have an x in common, which when we factor it out, inside will leave us with 2x plus 1. Minus 4x minus 2 has a 2 in common, but again, we want the inside the parentheses to look the same, so we're going to factor out a negative 2, which will then leave us with 2x plus 1 is equal to 0. So I've managed to get the parentheses to look exactly the same. Now, they both have 2x plus 1 in common, so I can factor that out from both. Factor that out, whatever is left forms its own parentheses. X minus 2 is equal to 0. Okay, so all I'm going to do here, I brought down this 3. I brought it down a little bit too far. That 3 is still part of our answer. Okay, so at this moment right now, this is factored form. Sorry, what I was going for was the highlighter. That's factor form, but directions were to solve it. Now we need to set each of these factors equal to 0. We are not going to set 3 equal to 0 because that would give us a statement that's not true, and it doesn't contain an x. So you're only setting the factors that contain an x equal to 0, which are the 2 in red. So we have 2x plus 1 equals 0, and x minus 2 equals to 0. Subtract 1 on the left. You get 2x is equal to negative 1 divided by 2. Turns out x is equal to negative 1/2. Part of my answer. Add 2 to both sides here. You get x is equal to 2. The other part of your answer. Alright, so we're looking at example 5a here. Example 5a says error analysis. So we're looking at somebody's mistake. Javier and Rosa were asked to solve the equation 6x squared minus 18x minus 24 is equal to 0. And then all the way in the bottom, who is correct? Identify the error, show your work, and explain your reasoning. So we have the work for Javier, we have the work for Rosa. We got to see who did it correctly. So we're basically just going to check their steps one at a time. We'll start with Javier. Now, they all start with the same equation, 6x squared minus 18x minus 24 is equal to 0. Right? Javier factors it out to 6x minus 3 and x plus 8 equals 0. Now, let's see if that's correct. I'm just going to multiply it together. So we have 6x times x, which is 6x squared. 6x times 8 was going to give us a positive 48x. And then we have negative 3 times x is minus 3x. Negative 3 times 8 minus 24 is equal to 0. If we combine like terms, we'd end up with 6x squared. 48 minus 3 would give us a positive 45x. And then bring down the minus 24 is equal to 0. So right away, we know Javier messed up when he factored out there. So everything that goes after that is automatically going to be incorrect because the initial step was incorrect. All right, so we're leaning towards Rosa potentially is correct, but let's double check her work. Now, we have here, she decides to take out our greatest common factor. Now, keep in mind, just because she took something out and she did follow the steps does not mean automatically that she is correct. There's always an option to say, hey, just like Javier did, I'm going to do 6 times negative 24, whatever that is. I'm going to figure out numbers that add up to negative 18. You could do that. The only reason it's not recommended is because you're going to end up with bigger numbers, and then to come up with factors of a huge number might take a little bit more work. All right, so Rosa realized that 6x squared minus 18x minus 24 were all divisible by 6. She took a 6 out, so let's just double check her work there. 6 times 6x squared is 6x squared. 6 times a minus 3x is minus 18x. 6 times a minus 4 is minus 24 is equal to 0. So it looks like so far she's okay there, right? We got back where we started. Now she factored x squared minus x minus 4 to become x minus 4 and x plus 1. So let's double check that work. We have x times x, which is x squared, x times 1, which is a positive 1x, negative 4 times x, which is minus 4x, negative 4 times 1, which is minus 4, is equal to 0. If we combine like terms, that gives us x squared. 1x minus 4x is minus 3x. Bring down the minus 4 equals 0. So that was actually correct too. And then at this point, remember, you set each of the factors containing x equal to 0. That's the reason we don't set 6 equal to 0, because that would give us a statement that's false, and 6 doesn't have a variable to begin with. So she took x minus 4, brought it down, added 4 to both sides. Sure enough, x equals 4. On the right, she brought down x plus 1, subtract 1 from both sides, and sure enough, you get the answers x equals 4 and x equals negative 1. So, time to answer the question. Who is correct? Rosa is correct. She followed all the steps correctly. Okay. Now, obviously that since it's not going to be enough, I'm going to be looking at your actual work, and I expect to see exactly what I have there. So like in between each line, you're checking to make sure that from one line to the next, it actually follows through. And then Javier factored incorrectly. Let's see. Factored incorrectly after the first step. Again, I'll want more than just a sentence as a proof. I'll be looking at all this work right here to justify both of your statements. 6A, you are constructing a frame for the rectangular photo shown. Okay, so this is the photo, and then this in green is the frame that you want to put around it. Okay, you want the frame to be the same width all the way around. Okay, so that's why there's an X on top, left, right, and bottom. And the total of the area in the frame, the total area of the frame, in the photo to be 145 inches squared. Write an equation to represent the total area of the framed picture and photo, and then factor and solve for X. So, the rectangle on the inside is the picture. The rectangle on the outside is the frame. We want the total area of the frame and the picture. So we want the area of the big rectangle to be 145 inches squared. So we need to come up with an equation to do this, factor it, and then solve for X. Okay. We're talking about area of a rectangle. We should be thinking about length times width. So length times width is equal to area. All right. So length is going to be from here to here. Now we know this little space right here is just X. This little space right here is just X. And then from here to here, based on the picture, we know that that is 25. So if we add that all up, that's going to be x plus 25 plus x. X plus x is going to give us 2x plus 25. So the length is going to be 2x plus 25. Now we need to find the width. We know that this right here is the width, and from here to here is x. From here to here is x, and thanks to the picture, we know that this is 1. So x plus x is going to give us 2x plus the width of the picture, which is 1. And that's area. We know area, we want it to be 145. Okay, we're going to ignore the measurement of inches squared right now. Okay, so we have an equation. Now we need to factor and solve for x. It almost seems like you can just at this point say 2x plus 25 equals 145 and 2x plus 1 equals 145, but they need to be set equal to 0. So we can't actually do that. So what we're going to have to do now is we're going to have to distribute. 2x times 2x is going to give me 4x squared. 2x times 1 is going to give me a positive 2x. 25 times 2x is going to give me a positive 50x. 25 times 1 is going to give me a positive 25, and it's still equal to 145. Okay, we can combine like terms. Here we have 2x and a 50x, so we're going to have 4x squared plus 52x plus 25 is equal to 145. Almost in standard form, but not quite. We need to subtract the 145 from both sides so that it's equal to 0. Okay, so now we're going to get 4x squared plus 52x, which will give us negative 120 is finally equal to 0. Okay, now it's in standard form. Now I need to factor that and multiply. Solve for x. Now, we could do the method here where a times c, but that's 4 times negative 120, which would give us negative 480. That's a lot of factors. So let's see if there's a greatest common factor from all three that we can factor out. Turns out they're all divisible by 4. So we factor out a 4. It's going to leave us x squared. And then you're going to have to do 52 divided by 4. That's going to give us 13. And then 120, negative 120 divided by 4 is just going to give us a minus 30. Okay. Again, this will be part of our answer. We'll bring it down later. I want to go ahead and start on the second column just because I need some more space. So we want numbers that when we multiply, well, I'll just rewrite the whole thing here. 4 parentheses x squared plus 13x minus 30 is equal to 0. Okay. Now we want numbers that multiply to give me AC. A being 1, C being negative 30. When I add them, give me B, which is going to be positive 13. Okay, 1 times negative 30 is just negative 30, and B is positive 13. So factors of 30 are going to include 1 and 30, 2 and 15, 3 and 10, not 4, 5 and 6, and I believe those are all of them. Keep in mind, one of them has to be negative for us to end up with a product of negative 30. 1 and 30 would never give us 13. 2 and 15 might. 3 and 10 also might. 5 and 6 would not. Okay. Now, let's say we thought it was 3 and 10. One of those has to be negative. If we made the 3 negative, negative 3 times 10 would give us negative 30, but when we add it, would give me 7. So what if I made the 10 negative? Multiplying them would give me negative 30. However, adding them would give me negative 7. So even though 3, 10 look like a possibility, it might be 2 and 15. If we make the 2 negative times 15, that does give me negative 30. If I do negative 2 plus 15, that does give me 13. So it looks like negative 2 and 15 are going to be the numbers that I want. All right. So again, we're going to bring down that 4. And then we're going to work with the middle. So rewrite the middle term. So we have x squared plus 15x minus 2x minus 30 is equal to 0. Cut it down the middle. They both have an x in common, so we're left with x plus 15. We can factor out a negative 2, we're left with x plus 15 equals 0. What do they both have in common? And x plus 15. And then whatever is left forms its own parentheses, x minus 2. And then the 4 from before. Okay, so we created an equation. We factored it. Now we got to solve for x. So each factor that has an x will be set equal to 0. So we have x plus 15 equals 0. And x minus 2 is equal to 0. Solve here, subtract 15. Turns out x is equal to negative 15. Add 2. Add 2. Turns out x is equal to 2. Those would be our two answers. Now, technically they're both answers. However, x represented the width of the frame. You cannot have a negative width. So, the final correct answer, x equals 2, is our final answer.